Oh, heck, this thing's been running for almost 30 seconds. Good morning. This is Pops on the 23rd of December, the year of our Lord, 2023. I had some part numbers I wanted to look up. And I thought I'd do a talk on here about cold weather starting with your tractors. Now, this is basic, generic stuff. But I mention it because it seems over the years a lot of people have forgotten an awful lot about it. One of the first things that I'm going to tell you to do before you do anything else is ask you if you've treated your fuel. By now, especially here in the Northeast, if you haven't treated your fuel by the end of October, I hope you were busy, because otherwise I'm calling you a fool. Yeah, a fuel fool. Well, it's treated from the... No. They'll tell you they treat it. They don't. They mix it quite often, yes, but actual treat, no. What do they call it now? Delphi? It used to be Stanadyne. They had a beautiful fuel additive. One guy claimed that, well, we're talking the second generation of diesel fuel, emission-style diesel fuel, and they started screwing with it. Dropped the sulfur down 50 parts per million. Yeah, when they got down there, we started having a lot of, I think it might even been 150. Then it went to 50, and now it's down to what, 15? Troublesome. They need it there for the after treatment. They don't need it there for the engine. They don't. That's why oils are so expensive. They had to find something else to replace the sulfur, take care of the leftovers from the combustion of the diesel fuel. So, and it can help keep the paraffin liquid, the sulfur. And there's ash content, a bunch of other stuff that all goes into it. But anyway, the first thing you check is make sure your fuel's treated. In fact, if it was me, I'd have it tested. Yeah, it's as crazy as it sounds. I'd pull some out and get a test tube. Don't pull any out and put it in the test tube. Take it right out of the nozzle. If you can dip it in the tank, great, but take it out of the nozzle, see what comes out, put it in a can, send it away for testing. Why? Well, because they might be able to find out what is or isn't in your fuel to begin with. You might be pulling water out and don't even know it. And the mysterious thing about water, diesel fuel or motor oil, it doesn't matter, pick one. Each are different types of oils, okay? And when they get involved in there, and as well as your hydraulic oil, any of it, once water is in there, if there's enough water to precipitate out, in other words, separate from the oil and lay in the bottom, because oil always rises, water likes to collect together in beads, and then it'll finally make a puddle. If it can do that, it takes and washes out some of the additives and impurities both and puts them in the bottom. And what do you got? Almost naked oil. So it's good to check the fuel content because it'll take out paraffin and other things. Paraffin for your lubrication through the system, but it'll also put it in a place near the bottom of the tank, near the outlet, where it'll plug. So if you have moisture in your fuel tank, your storage tank, you're going to have trouble. It's funny they call it storage, but it doesn't really store for very long if you're using it. Just a thought. But if it does sit for a while, then water naturally occurs. Somebody's going to tell you it naturally occurs. Yes, it does, to a certain extent. But test it and find out what's in there. So now you've got your fuel taken care of out there, or at least inspected. You know what you got. You know what you have to do to fix it. Fuel water separator on the pump is a massive help. Now you're going into your tractor. You got to be sure your tank, same thing. It's cleaned. Water treatment, something to separate and run the excess water through. Isopropyl alcohol is one that we used to use in a yellow bottle from Napa all the time. And we didn't even carry around any actual diesel fuel treatment because the isopropyl alcohol took the water, dispersed it into the fuel in such fine little beads that it shot right through the fuel system. And if you had a good fuel water separator, it would be able to travel through the system undaunted, and it would also keep the paraffin suspended. So you didn't gel up nearly as easily, if at all, and that would go through. Then if there's any crystals, they'd get caught in the filter rather than plugged in the system. And even there, if you have enough isopropyl in there, it'll finally clean things up and send it right through. And your fuel water separator would take care of the water, and if it didn't take care of the water, it would be in such small, it'd just go right through the system and hardly any effect at all. But the idea was to get it to, on the old systems, it didn't matter. The new systems, it's critical. Your fuel water separator is important. Not even so much the micron rating, your primary separator, but the rating of how well it separates water from the fuel. That's critical. And check it. And if you start getting a lot of water in there, you need to be draining your tanks and looking for external leaks or vents. Or one of my favorite is on my tractors, I always forget until it's too late. Snow will build up around your fuel cap, and fuel cap's vented. Well, it's not letting rain in, no. But if there's enough rain or anything that puddles, and there's snow that puddles there, as the tank changes temperature, air moves in and out, and it'll pull snow. Don't tell me it won't. But then again, it'll have condensation, and as the tank warms up, air comes out, tank cools down, air goes in, and it'll take some of that condensation with it and build it up in your tank, especially if your tractor's sitting for any length of time. All right, so your fuel system's tight. You don't have any air leaks. You've checked that, right? No, I know this sounds extensive, but it's important. Because as your fuel thickens in the cold weather, anything that's iffy that wasn't an air leak before, it is now. In the old Allis-Chalmers 7000 series, they had plastic fuel lines with no steel grommet in there to keep it from being crushed. So what wasn't restricted during the summer is a restriction now. A shutoff valve that's partly closed or has a problem, you can't fully open it. Wasn't a problem all summer, even in the fall. Now it is. Because anything that's a restriction, that'll separate your water and your paraffin, and you'll get crystals and plug. True story. Don't tell me. Your hand pumps, if you haven't changed it in 2 or 3 years, well, excuse me, 3 years and 2,000 to 3,000 hours is a good mark. If you have a separate hand pump, replace it. Don't even question, just replace it. Especially if you pull a hand pump up, release it, and bring it up, and fuel spurts out, just replace it. And they say, but it hasn't. Maybe it hasn't. Don't let it. Okay? There have been too many times I've been in the middle of a 50-acre field and tractor's out in the middle of nowhere, a quarter mile from the barn, and either I walked out there or tried to drive my truck out there as far as I could to get to the tractor, and in the middle of a field with the wind whipping 30 miles an hour, trying to open up the system so they could drive the tractor back. There's a couple times I had to tell the farmer, you're going to have to wait till the sun hits it or tow it back, buddy. So, you're nice. I don't care who you are, what you are, or how much money you have. Change your filters. They say, yeah, but you might have to change your filters later if your fuel gels up. Yes, but if you change them now, it's prevention. You can go longer without as much trouble. They're expensive, yes, on the newer systems. The old systems, not so much. But just replace them. It's a good bet. Now, if you're doing a full service, which to me is important this time of year, especially if you've got a tractor spreading manure, clearing snow, or even doing still some fall work, combines and such, yeah, change your oil and filters, all of it. Go right through it. Engine oil too. Why? Because you're in a different temperature range. And the oil from the summer has worn itself out. Do your fall or winter service. Why not? Get it done before there's trouble. So your filters are changed. You know your system tight. You're up to your fuel injection pump. Here you really can't do a whole lot. You know your engine's running good. Now switch over and check your heaters. Intake manifold heaters, your glow plugs that might be in the engine. Make sure they're working properly. Now, if you have a B series Cummins, 6.7 in particular, but even all the way back to the 5.9s and the 3.9s. What's the other one? The 4.5. Check if you got 2 or 3 years in and you use it during the winter, pull that manifold cover off of there and change that heater completely. Just throw it away and put another one in. Why? Because nuts and bolts and pieces fall off of it and go through the engine. Bye-bye. Depending on your engine, $20,000 or $30,000. Bye-bye. Yeah, because it usually ruins the block. I can get it bored. You can. Now it brings the cost down to $15,000 to $20,000 instead of $20,000 to $30,000. You really want to pay that bill? I do my own work. Okay. Now with parts, you're down to $10,000 or a little below. And you're without your truck or tractor. It's your choice. Fram, pay me now or pay me later. That's how that works. So, but check your heater, its operation. Now, when you do that, start with your engine off. Check your battery volts prior. Oh, wait a minute. Check your batteries, period. And the grid heater is a good test. It pulls 100 amps sometimes. Usually it slows down to about 30 to 50 amps. But now check your battery. Put a tester on there. Toasters are good to some extent, but I'd get electronic testers less than $100 now, about 50 bucks. You can get a nice one. Hook the thing up and it'll give you an idea of whether you have a bad cell or not. It does a little better reading. You've got a toaster? Good. I'm old school, but I love the new stuff too. The new stuff gives you a general idea how your battery's operating. Pull your cables off, clean up terminals and everything. Test the battery. Now put the toaster on there for a load, 10 seconds, pull it off, let the battery sit a few minutes. Go back and test it again. And if it's only down minimally, golden. Okay, now hook them up, clean everything up, hook them up, and run your grid heater or your glow plugs. Now after you've run those things for about 10 or 15 seconds, now go back with a temperature gun, unless you're one of those that has leather gloves and could feel heat. Go back through and find any hot spots all the way up to your heater. Yeah, it's important because you may look at a contact that's good, but you don't know that because of the heat that the metal has changed and corroded. And because it corroded, it's swelled. Yeah, it's tight, but it's not solid. If it's discolored black, you got a problem. Or if you start to see melted brass, copper, steel, you know you got a serious problem. But check your wires. See what the heat is of the connections in particular, but also the wires. Because sometimes you go along a wire and you find a spot that, hey, that's warmer than the rest. Yeah, because some of the strands are broken. I was trying to jam all those amps through a smaller area. Resistance, heat. So you're trying to minimize all of that so that your voltage drop. Your battery here might be 12.5, 13 volts. A lot of new batteries are anymore. I try to stay up for the electronics that start blinking at 10.5 and 11 volts when you get a surge load. Well, anyway, you check your battery, you turn your grid heater on, you say you're at 13 volts and it drops to 12.5, 12.75. You're probably good because you did your toaster test, you did your other test, now you did your grid heater test, and it's going to come down to about 12 volts, maybe 11.5. But let it go through its cycle. And then test your battery. And if it's still up there pretty good, you know your batteries are good. Now, it's rare with grid heaters and glow plug, it's rare you have one battery. It's usually two, or a big old 8D or 4D-LT or 4D battery. Excuse me. Anyway, so you know your battery's good. You've checked your wires, repaired those. Now you got your grid heaters working, most likely. And also you've tested your glow plugs to be sure they're going. What's the easiest test with a glow plug? Well, one of them is to get on through. They're all connected together in parallel. What's that mean? Well, they're all hooked on the same wire all the way down through. They may be looped. It might be a strap. But all your glow plugs are just 1 volt, one path to juice. And the thing there is, you've checked your connections. Everything's fine. How do you know the glow plug worked? Temperature gun. This is one of the easiest ways. Some of them get real hot. So what do? You turn it on, and while it's going about halfway through a normal cycle, go down through with your temperature gun, and when it clicks off, you know they're fully hot, and check each one all the way down through. And if you've got one that's much colder than the other, ding, 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 you got a bad one. What's the resistance in them? That's kind of hard to test. Why? Well, if they're all hooked together, you have a problem to begin with. But one of the things, if you really want to do some serious testing, other than the heat, you want to get down critical to it. Most are 0.5 ohm. And some test almost 0. So what do you do then? One of the things you can do is actually just take a connection wire from that lead, make a solid connection, and put it right on top of the glow plug that you know is a good one, got nice and warm, and then put an amp probe on it. Find out how many amps are flowing. And then go down the line and find out how many amps are flowing in each one of them. You might find one that's iffy. Instead of pulling 50 amps, it's 25. Well, now you know it's high resistance, so you have a problem. And if you're one of those that thinks like I do, you even think you got 3,000 hours or more, and you're in that far, put a new set in. Just get it over with. You think the grid heater's been in there 3,000 hours or so, and you're testing it, and something's not quite right, just replace it. Relay, replace it. Don't even question it. Just gone. I know it sounds nuts, but these are the things that prevent trouble later. In other words, if the glow plugs wore out, the relay's bad. If the relay went bad and you think the glow plugs are still working, I'm telling you, yeah, it's some work, but replace the dang glow plugs. If they're easily accessible, you get the 7.3 Power Stroke Fords. Some of the others that are underneath it, I'd be taking second thoughts there, but even then, without the glow plugs, they don't start. Anything that's a power cell engine or a pre-combustion chamber, like the old CAT systems, you want to be sure your glow plugs are pristine. You say, well, it's just one cylinder. Yeah, one cylinder getting flooded with stone cold fuel into stone cold air that's going to take a long time to build up heat, because stone cold fuel is spraying in there on top of the stone cold air, and each time it fires, it's supposed to do something with raw fuel in cold air. And that's why it's puking that bluish white smoke out. Stop it. Fix it. You're destroying your engine. It washes the cylinder wall down. After a while, it goes into the base and dilutes your oil. Okay? Fall oil change? Just saying. There's a reason for this stuff. So let's say all of that's fine, and you know the engine's running good in general. So pretty much you're set for the winter, except your starter. Find out how many amps the starter is drawing. You heard me. If you have to, unplug your glow plugs and then crank the thing over. If you know how to disable your fuel injection pump on the old stuff, just shut it off or pull the little solenoid and whirl the thing over with the amp probe on there. Find out how many amps the starter's drawing while it's whirling over. Get an idea of how the starter is actually doing. Find out what its average draw would be under that kind of a load. Call your local starter and alternator guy, or have him come and check it, or a local tech if you don't want to buy that clamp-on meter. But anymore, the clamp-on meter is a couple of $100 on most of your farms. Yeah, I know you're going to go to Harbor Fake and it'll be $50, and I'll sit there and cringe because sometimes they're okay. No, thank you. I'd rather you went to Napa or something to buy one, or get one of your Greenlees off the shelf of Lowe's or whatever. But you want a DC amp probe that can handle 1,000 amps. Like Spike. When you first crank it, almost every starter system pulls 1,000 amps for a brief tenth of a second. You just want to be able to handle a spike without destroying it. If it's digital, no problem. Analog, you might have a problem. Just be careful. But check it. Find out how many amps. Once the engine's whirling, it shouldn't draw much more than 200 or 300 amps in there into the motor, especially on 24-volt systems. They shouldn't draw a lot, but under 12 volts, half the volts, twice the amps. Twice the volts, half the amps. Repeat after me. Half the volts, twice the amps. Okay? Twice the volts, half the amps. Half the volts, twice the amps. It's an inverse deal. Get a 24-volt system. Because of the force of the 24 volts, you're talking watts into the system. You can have two starters, one 24 and the other 12. Yeah, it's not going to be exact, but that's the definition of electrical energy. If your 24-volt system and it's pulling 100 amps, the equivalent starter in 12-volt is going to draw 200 amps, give or take, one way or the other. I know, they both have to be gear reduction, identical, or not gear reduction, but you get the point. So that's something you can think about as well, especially for you guys that like to put 12-volt jumpers on your 6-volt systems. Let me tell you a secret about something. When you're running to guys that want everything original, at a 230 International, the place I work is not allowed to convert it to 12-volt. We couldn't get the thing to start right. It was cranking beautifully. It wasn't drawing too many amps. The coil was iffy. He says, but it runs. Leave it alone. 9 times out of 10, when it started, was you'd whirl the thing over, get the choke out there, and then you'd release the button and the choke at the same time, and you'd probably get it to pop off. Why? Because for a brief second, it's turning. There's still power to the points, but now the starter's not working. The voltage came up, and it would spark. Had new points condenser in it, had brand new wiring, had voltage check, everything was flowing all the way up, And the guy that worked on it before me that I worked right next to, he said, I did the same thing, and they won't convert it. The instant you put a 12-volt jumper on there, in other words, you start cranking, hit it with 12 volts, boom, start instantaneously, telling you that there was a problem in the system. He was a purist. Well, he was a cheap purist. I pulled a gallon of water out of the base of the transmission in the back end housing. He says, well, good. Now you got fresh, clean oil in there. No. Why? I drove it in here to do that. Yeah, it sat for an hour. Close enough. No. But that bonus check. Yeah, I've seen the results of it turn into Allis-Chalmers 180 and 185 transmission, 190 XTs, 200s, 190s, 170s, 175s, water in there, the damage, please. Oliver's, White's. I've probably done over 200 transmissions in 2 Allis-Chalmers dealers, and one of them was a White Oliver dealer also. Don't tell me just drain the water, it's okay. No. So anyway, if you know your starter's working good, your system's working good, one of the ways your starter works good too is your voltmeter on your battery. It might drop down to 10 volts, but once it's whirling, it should come back up 10.5, 11 volts. That'll be enough for your computer. That's one of the reasons a lot of these systems, you turn the key with a computer-style system, it whirls over, and it takes 5 to 10 seconds, even in warm weather, before it even fires. It has the droop of the amp surge. When the amps go down, volts go down at the same time out of the battery because it's pushing it, and so many amps are going out. Battery can't quite keep up with that kind of discharge. And then as it whirls and settles in, both of them, the fewer amps, okay, I should do it the other way around. Amps go up and the volts go down. And then as the amps aren't required, the voltage comes back up, triggers your control unit, then off you are to the races. Just like the 6-volt ignition system, the exact same thing, only on a different system altogether. Same idea. Volts and amps in a battery inverse. More amps that go out, the volts drop. Fewer amps go out, the volts stay higher. But if you already have a high flow and then you bring the amp flow down, the voltage will come back because the battery is able to handle that kind of flow. Just basic logic, like your faucet. Same idea, you know. You open. So just think about it. Anyway, now that you've got all that settled, you should be able to have a machine that'll start fairly well. You've put water treatment in your fuel system to clean that out. You've treated your fuel in your storage tanks, and if all it is 5-gallon pails, well, then I suggest you get your 1/4-gallon bottle and have a measuring cup. And if it tells you put 2 ounces in 5 gallons, then measure exactly 2 ounces and put it in your 5 gallons. If it says for long-term storage, put in 2.5 or 3 ounces. Well, if you know it's going to sit for a week or more, then use the long-term storage. Trust me on this. It's worth it. And the guys will have a fit. You got to put it in when you fill it because it mixes better. That's all true, but it's not necessary. Just pour it in there, give the can a few shakes. It'll get itself around there. How? Diffusion, capillary action. What's the other one? Osmosis. That's water across the membrane. Diffusion is stuff across the membrane. No, it's not cells in there, but it's the same idea that eventually it mixes its way around. Especially if it's lighter than the fuel, it'll get in there and start mixing and go down. Just shake it. It'll be fine. If you're concerned, pick it up and really shake it. Just don't tumble it. Make sure the top is tight. Don't put your hand over it and shake it. Duh. Now you say you've put regular fuel treatment in there, and now you're thinking of putting in some isopropyl alcohol. If it's standard fuel treatment, I'd say you're okay. Put a little isopropyl in there. Measure the amount to put in there. If it's going to sit for a length of time. Otherwise, I would say wait. And when you put the fuel in the tractor, put in the commensurate amount of isopropyl alcohol with the 5 or 10 or 15 or 20 gallons, whatever you put in there to mix with it, while it's in the tractor itself. Why? Well, because A, it's going to mix better when it's in there, and B, it's going to dissipate through the whole fuel system in the beginning, and you don't have to do it. Usually, if everything's clean and up to snuff, you only put in a little bit now and then. You don't have to put it in every tank full. Every 2 to 3, every other tank full, every third tank full, something in that. And if you're one of those that's a purist that doesn't use it and you're not having any trouble, rock on, dude. Go for it. What do I think about 911? Only if you need it. However, if you think you have water in your system and it's not gelled up yet, but it's running funky, put in the appropriate amount of Power Service 911. It'll work wonders for you, because it does have something akin to isopropyl alcohol in it. All right, I've done enough talk. We're coming up on 30 minutes here. The only other thing I'll say after this is, if you have a system that's approaching 5,000 hours and you use the tractor almost year-round, but specifically in the wintertime, I don't care what type of injection system it is, please consider either replacing or servicing your injectors. Some of the old ones, what we used to do is, cheap. You could buy a nozzle tip back 30 years ago for 10 or 15 bucks. You kidding? We just pull it apart, clean it up, change the nozzle, check it to be sure it didn't leak, adjust the pop, and put it back in. Cheap. Even paying us in the shop at $30, $40, $50 an hour. They were way ahead of money. So now it's going to cost you something. Some of your new injectors, they're electronic. You can't test them anyway because you need a pulse box. Well, if you have one, knock yourself out. I don't think it takes much more than the pulse of an actual car fuel injector. Even though there's higher pressure in there to actually activate the bugger on top, I don't think it takes that much more. But that's what I've heard from guys that have tested them. So, but if you're at home, you can pop test them. You can buy a pop tester off of Amazon for a couple of $100. And if you're somebody who doesn't do a lot in the wintertime, like crop farmers, beef farmers, why not? Learn how to do it. Now, some of them are different, but most of the nuts on the bottom of an injector that hold the nozzle tip on are 35 to 50 psi, or foot-pounds, psi, foot-pounds of torque. So, and I could do it by feel. Literally. Have a nice long combination wrench, get it in a vise. I had a holder, but some guys can do it in a vise well. And all the holder was a nice heavy plate with 2 heavy bolts that went right up in the holes. And others, you just have to hold them in the vise, smooth jaw vise, on the 2 flats on the side of the injector. Pop that sucker loose. Most of the new smaller ones are 35 foot-pounds. And the older bigger body ones, not the monstrosities, the big body power cell and such, are 50 foot-pounds. And then you can do that with a nice long combination wrench very easily. Once you turn it about 1/8 of a turn, it's all off. All your torque. Just pull it off, clean it up. Brass brushes, stainless, you got to be careful. Well, quite often they like brass on the things, but stainless will work. Why? Well, you have to be careful and make sure your brush is larger than the hole of the injection tip that you're working in. But if you're replacing the tip, you're not actually trying to hand lap it and clean the nozzle holes out. Don't worry about it. Just clean it off enough that you can get the nut off, clean the nut out, and put her back together. Just make sure everything is clean. Did I say clean? Clean. Clean. And some of them you may have to take back apart again to shim to get your pressure up there. They want it usually like compression within 10% across the board. So if you're supposed to be at 2,000 psi, yeah, you can vary a little bit. 200 pounds though? No. If you're supposed to be at 2,000, I'd want to stay someplace between 1950 and 2050. So that puts you in 1% maybe. But that's a nice wide range, and it will work fine in that range. Not at all. Now, your injection pump's worn, you don't have any money. You know it's running, and you got to keep it going. Now, the last thing I'll put on here, because we're coming up on 30 minutes, is that what we used to do was when the pressure started getting over 2,500 pounds and the pumps would get worn, tractors wouldn't start well. And what we would do is take a 3,000, 4,000, 4,500 psi nozzle and bump it down 500 pounds. It changes your timing slightly. Now it injects a little earlier, but your pump's worn, so it's not going to inject any earlier if your pump's worn that bad. If you do that with your tractor, you're probably going to get a little bit more smoke, But at the same time, you may be able to take a weak pump and extend it another season before you afford to replace the pump or trade the tractor in. But you'll be surprised that if you have similar pressures all the way across the board, how well that'll run. The main reason they had high pressure was atomization. It isn't absolutely necessary to run at 4,000 psi, but they do run better. The pump is designed to time it at 4,000 psi. That's the timing setting. So anything you do to drop it may help it start, but it may smoke more at startup and while it's running. Just something to get used to. But it may help you start in the winter. Anyway, that's enough. 30 minutes and 54 seconds. This is Pop signing off. Merry Christmas.